Hello, you are welcome to solve this equation. We have x raised to the power 2/3 plus x raised to the power 1/3 is equal to 1. So the first thing we're going to do is just rewrite the first term differently. So you can have it as x raised to the power 1 over 3, and the whole of that is raised to the power 2 plus x raised to the power 1/3 is equal to 1. So as you can see, we have x raised to the power 1/3 being common. So we can as well let x raised to the power 1/3 be another letter y. So if this is the case, remember what we're solving for is the value of x. So we can rewrite these in terms of x. So we can do that by just cubing both sides of this equation. So that cubed is equal to that cubed. So that x alone will be equal to y cubed. So now let us rewrite this equation in terms of y. So we're going to have y squared plus y is equal to 1, which we can also write as y squared plus y minus 1 is equal to 0. As you can see, this is a quadratic equation which you can use a quadratic formula to solve. So let us do that. Let us use the quadratic formula. Remember, the quadratic formula says that you can get this value by taking minus b plus or minus the root of b squared minus 4ac, and this is over 2a. So it means we have to identify the value of a, and the value of a in this case is 1, and the value of b in this case is 1, and the value of c is negative 1. So all we need to do is just substitute these values into our quadratic formula, so that y is going to be equal to minus b, that is minus 1, plus or minus the root of b squared, and b is 1, minus 4a times c, and that is all over 2 times a. So let us go ahead and simplify this. So we're going to have that being equal to minus 1 plus or minus the root of 1 squared is 1, then minus minus, that is 4 times 1 times negative 1, that is plus 4 over 2 times 1. So this melts down to minus 1 plus or minus the root of 5 over 2 as the value of y. But wait a minute, we are looking for x, not y. So from here, we can see two values of y. So we can name them y1. So y1 is equal to minus 1 plus the root of 5 over 2. And y2 is minus 1 minus the root of 5 over 2. So you can use these two values to get two values of x. So let us recall the relationship between x and y. We said that x would be given by y cubed. So we can take the first x using the first y. So it will be this y here, that is minus 1 plus the root of 5 over 2 cubed. That is what will give us x1. So let us write this as a binomial, that is minus 1 over 2 plus root of 5 over 2, and the whole of that is raised to power 3. So as you can see, we can simplify this as a binomial, meaning we are going to use binomial expansion to simplify this. So let us do that. So we can get the coefficients of this expansion from Pascal's triangle. Remember, when the coefficient is 0, when power is 0, the coefficient is 1. When the power is 1, the coefficients are 1, 1. When the power is 2, we have 2, then 1, 1. But when the power is 3, we have 1, 3, 3, 1. So we're going to use these in our expansion. So it means for our coefficients in this expansion, we have 1, 3, 3, and 1. Then we're also going to observe how the powers of a and b change across the expansion. So a in our case is negative half. So we're going to take the powers of a are reduced from n to 0. So it means at the beginning we're going to have minus half raised power 3, then minus half raised power 2, then minus half raised power 1, and finally minus half raised power 0. So we can simplify this. When we simplify this, we're going to have this will be minus 1 over 8. This will be 1 over 4. This will be minus 1 over 2, but this will be 1. Then now the powers of b normally increase from 0 to n. So in our case, b is root 5 over 2. So let us see how root 5 over 2 will change across the expansion. So you have root of 5 over 2. So at the beginning it will have a power of 0. You have root 5 over 2 power 0. Then root 5 over 2 power 1. Then root 5 over 2 power 2. Then finally root 5 over 2 power 3. So we can simplify this. This is power 0, so that is 1. Then here we have just root 5 over 2. Here we have root 5 squared is 5 over 2 squared, that is 4. And here we have 5 root 5. Because when you cube this, you should get 125, which is 5 root 5. Then over 2 cubed is 8. So now what we're going to do is multiply from here downwards. So we're going to have 1 times negative 1 over 8 times 1, and that will give us minus 1 over 8. Then we're going to have 3 times a quarter times root 5 over 2. So that will be 3 times 1 times root 5, that is 3 root 5 over 4 times 2, that is 8. Here we're going to have 3 times negative half times 5 over 4. So that will be negative. So we have 3 times 1 times 5, which is 15, over 2 times 4, that is 8. Then we have 1 times 1 times 5 root 5 over 8. So that is plus 5 root 5 over 8. So as you can see, everything here is over 8. So it means we can write these with an LCM of 8. So that we have 8 over everything that is minus 1 plus 3 root 5 minus 15 plus 5 root 5. So if we collect the like terms, we have minus 1 minus 15, that is minus 16, plus 3 root 5 plus 5 root 5, that is 8 root 5, and all of these is over 8. So as you can see, 8 is common in the numerator, so you can have 8 into minus 2 plus root 5, and that is over 8. So 8 here once, 8 here once, will mean that x1 is equal to minus 2 plus the root of 5. So we can also use y2 to obtain the other value of x. Remember, y2 was given by minus 1 minus root 5 over 2. So it means x2 will be minus 1 minus root 5 over 2 cubed. Again, we go ahead and write this as a binomial so that we have minus 1 over 2 minus root 5 over 2. And all of this is cubed. And as we had seen from the previous solution, we can use binomial expansion to simplify this. So the coefficients, as we had seen in the first solution, will be 1, 3, 3, and 1. And b in this case is negative half. And as you know, the powers of b, or not b but a, the powers of a reduce across the expansion. So it means at the beginning we're going to have minus 2 raised to power 3 minus half raised to power 2 minus half raised to power 1 and minus half raised to power 0. So if we simplify this, we're going to have this is minus 1 over 8. This is 1 over 4. This is minus half. And this is just 1. So the next thing is to look at how the powers of b will change across this expansion. So b in this case is minus root 5 over 2. So at first it will have a power 0. So we have minus root 5 over 2 raised to power 0. Then we have minus root 5 over 2 raised to power 1. Then minus root 5 over 2 raised to power 2. Then we have minus root 5 over 2 raised to power 3. So we can also simplify so that we see what we get here. So if we simplify, here we are going to have 1. Here we're going to have minus root of 5 over 2. Here we're going to have 5 over 4. Here we're going to have minus 5 root 5 over 8. Then the next thing is just to multiply down. So we're going to take 1 times negative 1 over 8 times 1. That will be negative 1 over 8. Then we have 3 times a quarter times negative root 5 over 2. That will be minus 3 root 5 over 8. This is 8 too. Then we have 3 times negative a half times 5 over 4. That is minus 15 over 8. Then here we have 1 times 1 times 5 root 5. And that will be minus 5 root 5. And it is over 8. As you can see, all of these have what a denominator of 8, so you can as well write everything over a common 8 or a common LCM, which is 8. So that is negative 1 minus 3 root 5 minus 15 minus 5 root 5. So if we simplify, we have minus 1 minus 15, that is minus 16. And minus 3 root 5 minus 5 root 5 is minus 8 root 5. And this is still over 8. So as you can see, 8 is common in the numerator. So we can have everything into 8. So 8 into minus 2 minus root 5 over 8. So 8 here once, 8 here once, so that our x2 is equal to minus 2 minus the root of 5. So our solutions are x1 is equal to minus 2 plus root 5, and our x2 is equal to minus 2 minus root 2. Those are our two solutions. So thank you for watching. Please, if you're new here, support the channel by subscribing. Thank you and see you in the next video.